Hello, ladies and gentlemen. Today I'm going to show you a piece of equipment here that's going to allow us to break water. So let me take you through the equipment, show you how the reaction works, and we're going to discuss a couple findings and demonstrate how we know we have at least one of the components of water. So here, a couple tubes, upside down, you can see, connected to valves, which will allow me to open up and let any gas that's trapped in the top of the tube escape. These tubes, they're connected down here all together and up through here. So all three of these are all connected, and they all have the same water throughout all of these tubes. At the bottom of each of these tubes, with the stopper in place, are little electrodes connected to an electricity source, a voltage source. And so when I turn on the electricity, it's going to zap the water, and with the little electrodes, that electricity is going to rip the water apart into hydrogen and oxygen gas, because water is made of, H2O is made of hydrogen gas and oxygen gas together. Now what will happen, what we'll notice is the gas from the electrodes where the water is being ripped apart will rise in the tubes, and that's going to force this water downward, and that water's got to go somewhere, so it's going to go back and up here. So we'll find that this water level will rise as we let this go, because the gas is going to build up here. And what we're going to have to decide is, well, which gas is which, and how do we know which is the hydrogen gas, which is the oxygen gas? For full disclosure, in order to get that electricity to flow through the water, because remember, water by itself doesn't really conduct electricity. We do have just a little bit of baking soda in the water. So it's it's ionic, it's an electrolyte, and it allows the electricity to flow a little better, so that the water can get ripped apart at the electrodes. So what we'll do is we're going to turn it on, and I'm going to turn up the voltage. You can see maybe in the camera, I hope you can see that there's bubbles forming. You'll see that one side's a little more vigorous than the other, especially if I really pump up the voltage, the electricity. You can see, hopefully you can see little bubbles rising in the tubes. And I'm going to let this gas build up a bit. I'm going to actually turn it down to make it a little less violent. I'm going to let it sit for a while. And we'll pause the video, and I'll cut out some of the waiting time, and we'll come back to it after we've built up a bit of gas, and then we'll discuss, well, which gas is which and how do we know. Okay? All right, so hang in there. We'll be right back. So here I have a close-up of looking at the electrodes producing the gas. You can see the one is a little more vigorous than the other. And if I go up top, we can see that the gas is building up at the top of the tubes, and it's trapped. As that gas builds up, like I said, this water level at the top of what we call a thistle tube, that level will rise. So we'll let that go a little bit longer and come back to it and show you some more footage. Okay, so we've been letting this go for several minutes, and we can see that, the gas levels here are different, and I haven't touched them. But as this thing has been going, the one side's producing bubbles and gas faster than the other side. And you can definitely see a difference in the volumes. You can also, of course, see that that water level is rising in that thistle because it's being pushed out of the tubes. So the question is, well, which of these gases is the oxygen and which is the hydrogen? And it's kind of easy to tell if you know the formula of water. H2O. H2O. For every 2 hydrogen, you have 1 oxygen. So with that kind of in mind, who is who? Who's on the left and who's on the right? Go ahead, take a guess. Hydrogen. Hydrogen is on the left. H2. 2 hydrogen. You have double the amount of hydrogen than you would the oxygen. That's about a 2-to-1 ratio in volume. There's another way I'm going to test this. I'm going to show you how hydrogen gas reacts. And we're going to prove that it's hydrogen. So, give me a minute to set up, and then we'll do that. Okay. We've built up quite a bit of gas. We said that oxygen here, lesser volume. Hydrogen here, higher volume because H2O. We can also tell that from the charges here. The oxygen, typically a negative charge, is attracted to the positive side of the voltage, and the hydrogen, which is typically a positive charge or slightly positive charge, is attracted to the negative side of the voltage. But you aren't familiar with that yet, so I wouldn't have expected you to know that, but just for background knowledge. The other thing we can do is I'm going to turn this off. We're going to test the hydrogen gas. I'm not going to test the oxygen gas because number one, it's not enough, and number two, oxygen gas tends to be a little heavy, so as soon as I open this up, it's going to kind of just fall and disperse to the atmosphere. But hydrogen gas is really, 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 really a light gas. I mean, it has a very low density. It's going to want to rise. Hydrogen has such a low density that it rises through our atmosphere and sometimes even escapes out into space. So what I can do is I can catch that hydrogen gas in this test tube. As long as I put this test tube over and just hold the test tube here, most of it will stay in here. Some of it, oh, there goes the bell. You get a bell in the video. Some of it will escape, but most of it will stay in here. And if I do that, I now captured it. And if I take my lighter, hydrogen gas is very, very, very explosive. And I can make it explode in my test tube. And that was lame. So I'm going to reset this, do it again, and make it good, because that was garbage. We'll be back. All right, let's try this again. Firstly, you know what I really should do? I should show you that this is a clean and dry test tube. So I'm going to bring this over. And you can see it's a clean and dry test tube. And what I'll do, I made lots and lots of hydrogen gas here, so I'm going to catch quite a bit of it. All right, and that should stay pretty trapped in there. Hydrogen gas moves pretty quick, so it does escape pretty easily. And then what I'm going to do is I'm going to pop it. Yeah, that bark. That's a hydrogen test. It's exploding in the test tube. And if I bring the test tube over, because it reacted with oxygen in the air, you might notice barely a little condensation in there. Let's see if I can put it in front of me, see if I can show some of the condensation that's in the tube. And that's water. Because I took the hydrogen that was in here and oxygen in the air and a little spark, and I put oxygen and hydrogen back together again and made water again. And it's not a ton of water, but enough to hopefully see the condensation. So that is called electrolysis of water. We ripped it apart and then pop, I put it back together again. So we'll talk about it a little more in our notes. All right, thank you.